Hello everyone. Uh, this is a project that I have done as a part of CFD course. My topic is turbulence modeling of ARN2 Axisymmetric subsonic jet. So I got this idea of doing it from one of the NASA paper that they have studied to understand the normal turbulence modeling in a simple geometry, and I was interested in doing this and I chose this project. So in this, I will be showing you how I was able to do this using computational fluid dynamics using ANSYS Fluent. But before we go through, I'll just walk you through what the project I am doing right now. So introduction. So we are using axisymmetric subsonic jet. So this is a sketch. I'll be mentioning you more where I got this sketch and all from. But why we are studying it? It's an ideal case for validating CFD turbulence model. Even though the geometry is simple, but it's very rich in turbulence physics. So with this, we can understand lots of about turbulence physics, and also we'll know that how the high-speed jet interacts with the still surrounding air. So it was a good paper that I understood, and I was able to simulate it. And the key features or the objective is that we are doing this in the 2D axisymmetric CFD model. And here we'll be seeing the jet core length, shear layer development, and how velocity decay is there. And we will be comparing our result with how the NASA paper they have, whatever the paper they have published, and we'll be trying to accumulate with that whatever the value they have got and the contours they have got. We'll be measuring that, and at the end we'll be able to show that yes, how CFD was able to accurately depict the experimental model. So before we go through again, these are the fundamentals, importance, and applications. So the basic fundamentals is that the software, it solves Navier-Stokes equation numerically, and it models fluid behavior, velocity, pressure, turbulence, heat mixing, and so many other things. It tried to model the fluid behaviors, and even used the discretized grid and numerical method. The importance is, of course, it reduced the cost and time of the experiment, help in designing the optimizing the design, and it's very essential for analyzing complex flow, difficult to measure, which are difficult to measure. And we have some applications in different domains in aerospace, automotive, energy, manufacturing, research, and so many other. So right now it has become a very important part, and though it's complex, but uh, it predicts real-time behavior, saves money. So it's a good topic to study and go through. So before I go ahead, so it's better that I will show you how and where I got this idea from. So this is the paper, uh, Turbulence Modeling Research Center from Langley Research Center. I got this, and so this is the one we are going to model it. And so we have not all the data, we have few data, but with this data, how we are able to solve it, uh, we'll be doing it. But before we go through this domain, the important part is this inlet, the axisymmetric jet that we are going to study. So this nozzle, even though in this paper they have not described the exact design, how they were able to make it, but after finding in internet, I found a very similar nozzle design. This one, yeah, this is ARN2, and this is the basic sketch that they have shown. So since this is an axisymmetric jet nozzle, we'll be trying to replicate this part. And so for this, what we have is this point. So from x equals to 0 to 6.85, and then there is equation. So with this two, we'll be able to replicate this. So what I did was, for the geometry, uh, even though we can make this in ANSYS design modeler, but uh, I find it a bit, I'm more comfortable in SolidWorks. So only for this part, I use SolidWorks. And so what I did at starting was I plotted around 200 points between these two regions and replicate this equation. So if we go to this Excel, yeah. So from 0 to 6.825, yeah, I have plotted 200 points, and in this is the equation that was able to generate. And what we'll do is we'll save this so that we can import in SolidWorks. So while saving, it's important that you save in txt file. So I have already, yeah, txt file. So I can, you can even do this uh, other way, but I think txt is more comfortable if we start to import it. So I have already saved it. I'll show you directly how I got this file. So, okay. So here is the SolidWorks. And before we do anything, before we try to import it, so it's very important that we should know about the dimensions. So in this paper, whatever the dimensions they have used, it's in inch. So I tried, and since I want to replicate the values and all, I try to stay with the inch. If you want, you can even convert to other ones, but I was comfortable doing it in inches. So uh, select inch. Now we can import. So okay, so let's insert. Insert curve and curve through XYZ point. Now we'll browse. So text file, yeah. So I have saved this as a symmetric nozzle. Let's open this right here and let's click OK. So here we have. So it does replicate the same that we are trying to see in this one. But yeah, we have this line and this line attached to it, and that's what we are going to uh, develop in the SolidWorks. So I'm focusing on this region that we can see. So uh, let's try and make this design. So before we do anything, I think it's important that since it's a curve, I want to make it a part of the design. So I'll just do select this and I will do convert entities. All right, it came like this. So converted the entity. So at first I was having some problem with converting entities, but yeah, finally I did it. So now will be this sketching, and all right, let's try and replicate that. It's like this, like this. Okay, so I think this is good now. So yeah, this is at the origin. As I try to make it like that, this is in the origin, and this should be. So now we'll be doing the dimensions. So this, I can see that this line is around 0.250 and this is around 0.665. So okay, let's dimension this as 0.25 and this as 0.665, and then okay, so this we don't know exact. So what we'll do is we'll do a line construction line. So at this point I'm gonna make a small construction line. Oh, and then I will dimension it. So how I'm gonna dimension it, that we know that from this it is around diameter of 8.5. So we'll use this, and yeah, so it's 8.5. Yes, 8.5. All right. So this is good now, and this in this paper it has given an angle of 30 degrees. So this part, this part should be 30 degree. All right. So I think we are good with the basic geometry of the curve, and I think this should be it. But yeah, since we'll be importing this in ANSYS design modeler, one thing that I have encountered is that you need to uh, select the plane. So like how we can do that is go to insert, and then in the insert you can go to surface, and then this planar. Okay, so select this, and I think this should be it. Now we can do one thing, we have to save this, but while saving, you have to save the SolidWorks file, and also since we have to transport this to ANSYS, use the step file. So here we'll be using the step file. Where it went? Yeah, this one. So once you save this, it will be ready to. So I have already saved the one file, and so I don't need to save it again. I was just showing how you can do this. So you can use this, and we'll be able to import this geometry in ANSYS. Let's open the ANSYS now. Yeah, so I'll just be removing the small parts like opening on software and all because it takes some time, and I'm just skipping that part, and I'm just directly jumping into the main thing that we are doing here. So I have already done this. I have already said that I have done this and used this as a presentation. So we might be wondering what these two different files are. So this one I did as a steady state. I just wanted to know how in the steady state it looks, and for this I did as the transient. So in this I will be showing you both and how you can do both. There are some small parameters that we need to understand, and so let's jump into drawing one. So this, since we are doing this as 2D, make sure that you do this as 2D before jumping into design modeler. So now new design model. All right. So now we'll be taking care of the remaining part that was in the geometry. So if we go back here, yeah. So now, and yeah, also one thing that they have even shared grid independence uh, kind of graph. From this, at least we'll know that what's the domain size. So in this, we can say it's around 50. This is around 60, and this length is from here starts as 80. So we'll be keeping that in mind, and we'll be drawing it accordingly. So let's jump directly to that. I think yeah. So the first thing we can do is let's import the geometry, external geometry file, step file is. So I already have the step file, and I will keep at frozen. So let's generate this. All right. So we are able to successfully uh, replicate the geometry that we did in SolidWorks, and now we'll be doing the further part. So even though we didn't change the unit here, but since we have imported it, I don't think it will be changing to the meters. Yes, so it doesn't change. So it's in inches, and it will make sure that it's the whatever the dimensions we have done in SolidWorks, it will remain in the same form. So now what we will do is we will be doing the sketch. So on the XY plane, let's sketch. So from this, we know this is, uh, we have a line over here. So sketching line. So just making it arbitrary. I will be dimensioning it later time. and then so it's going a bit back. So what we can do is so uh, we need a line that passes through this and then goes like this. So for that we can do one thing, construction point. So somewhere around here, let's say over here, I did a construction point, and I will extend this from here to so no extension for it's all right. We'll just delete it then. So I don't think we have to delete it because I think yeah, it has been extended. So now from here, let's draw a line. So it should be somewhat like this. Okay, we'll be dimensioning it anyway. So let's don't worry about this. We are making it arbitrarily. Should be it, but we need this vertical. So and the constraint, I want this to be vertical. All right. But we have a problem here that we need to make it similar, and we need to make it exactly align on this line, or else once we do the boolean, it will be creating a problem for us. So what we can do is, so two dimensions we need to know. One is the dimension between these two, and the other is from this two. So again, we'll go back to the geometry, and from this, if we can see that this is 0.665. So we know that this is 665. So let's do the dimensioning. The horizontal dimensioning. So this line and this line should be 0.665. All right, so it's aligned on this line. The other thing we have to do is vertical ones, this and this. So what will be the dimension of this? So we know that this is the diameter, so it will be half of this from this line. So it should be 4.25 and should be 4.25. And that there you go. So I think it's aligned exactly on this. And all right, so now the other dimension is from here. Oh, sorry, it's from here. So this is 50, this is 60, and let's see what we'll be doing here. Let's do this. Let's do the general. So we know this is V3 is 50, and this is V4 is 60. All right. So now the main thing comes is what should be. So again, from this, it's showing 80 from here. And so what should be this dimension? So let's calculate that. So if we'll calculate this 0.25, and this is 6.825 and 6.665. So it's around 7. So what we can do is we can just dimension this, equal this and this. Yeah, general. So don't need to be cancelled. Okay. So let's dimension this. So I don't know why it's doing the same thing again and again. So this was able to come, and this will keep as 80 plus 7 is length from there, so let's keep at 87. All right, I think we are good with the part here. Okay, so now once we have completed all the sketch, everything looks good from here, and then we'll go to concept, surface from sketch, sketch 1, make sure everything is sketch 1, and then apply, yeah, and generate. Okay, so everything looks good now. So now we have to do the boolean, create, go to boolean. Here we have to subtract that part, so we'll be subtracting it. So in this, the target body should be the one that has to be targeted, the big word. Let's select this, and for this you have to select this one. So if you try to do this again, it will select like this. So we can do is and click here, and this body will select. And let's apply, and once you generate it, all right. So it's look good now. So let's find it out. Okay, so from here, not this. All right. So yeah. So what thing we can do is, yes, select this, but let's remove this zoom part. Okay. So now if we start selecting each line, let's not select the sketch modeling. If we select the, okay. So yeah, we can see that we are able to select each one separately, and I think that yeah, and should be good now. One thing, so I just need not to change anything. So what we can do is we can just uh, freeze it. All right. Uh, I think it's an important thing to do. And this makes everything uh, and good, and freeze it so nothing changes. Now, if you see, our geometry is done, but the other important thing is that so now we'll be doing the mesh. But before we do the mesh, we need to understand one thing, that we need to get something like this. So here we can see it has been meshed in different faces. So before we go to mesh, we have to make sure that it should replicate somewhat around this. So for this, I tried different things, but uh, and I didn't get result on so many things. It was creating some problem in mesh, but ultimately what I did was I tried to make some lines. And how I was able to do it, I'll be able to show you right now. Okay. Yeah. So what I will do is I'll make one more sketch. So I don't want to interfere with the previous sketch. So let's make sketch 2 and go for sketching. Okay, so in this, what I want to do is, if you see in this, uh, so they have made some lines or something like that. So I'm just gonna see how it will be good, and once I make it, it will be easier to visualize too. So what I will do is, before I make a line, I just want to make sure that it's exactly at this edge. So if you zoom it, just want to keep it exactly here. and the other should be exactly. So we need to dimension this point. So because if we don't dimension it, once we do the miss, it will create unwanted edges, which we don't want. So this point should be exactly at that point. So now to make sure that this is exactly aligned, dimension is required. So how we can dimension it as vertical. So we know the vertical length, right? So if this, okay, so this has already been the same. So we don't need to do this. We only need to take care of the horizontal ones. So for the horizontal, uh, we can do one thing. Yeah. So you can just go back and try to measure this. And if you are able to measure this, I think it will come around 2.1108. I have already done the measurement. So if you do go in, you can just go in SolidWorks and start measure from here to here. So you will be able to get the exact point. And let's dimension this. So this point, this line is, this is 2.1108. So even though we are using only four after decimal 4 point, once you go in SolidWorks, you will be having more points number than that. But once you paste it, it will give you the same thing. So we'll be only considering the 4 points after that. Even though the numbers are large, if you paste it exactly, the final number is gonna be. So we should not be worrying about that. I think so. I think this point is now very nicely done. At this point, okay, we'll check that. So now this. So for this other point, we can have to do the dimensions again. Total dimensions. So what's the exact dimension of this to this? Before that, yes, but we know one thing, that dimension, the length from here to here is around. Once you calculate this, calculating the length of this, and length of this as described in the geometry. So like this is, we know 6.825, this is 0.250, and this is 0.665. If you add this all, you will get around 7.74. So I'll be dimensioning that. Okay, so this point and this point should be okay. So it's very much at the time. Just make sure 7.74. All right. Now we need the vertical dimensions. So in the vertical dimension, what I thought was, so if you say this, uh, it should replicate to the point that we have already plotted in the Excel. So if we see, so at this point, this is the number we are getting. So I think this is the one that should be the dimension of that. And let's try and do that. So the value is 0.999496. Okay, let's do this. Vertical, this point, and this should be 0.99996. So even if you want to plot, if you see a number like this, for example, oh, it will show you a big number. Sorry. It's okay, it's not coming. So if you want to see, it's not only the four numbers we have, we can do like this. Yeah. Okay. So this is the one I think I wanted to show you. So this is a large number, but as I said, even if you paste this in ANSYS, it will show you the same exact number that I did already. And here we are at. So now I think that we are good with the points. I think it has exactly aligned here. And this is exactly aligned. Let's see this. Let's go. Now, the important part is that let's extend the line from here because for that we have done the construction point. So let's extend this line till and then we have to extend another line. So even we need a line, I think, over here. So because I mean I want to make a different compartments for missing. So what we can do is we have made this line. So we need three different lines. So okay, let's do one thing. We'll make a line straight. All right, uh, this looks good, but even I want to make a line over here, so I'll just simply, all right, yes, and let's make a line over here. It will be in a particular dimension, so it should not be a problem. So let's make one line, say, at some point, yes. And one more thing is from this figure, we can see it's go even there is one that's going at some point. We don't know the exact number, but from this is 10, so should be 5. So we can just dimension this too. Yeah, from here, this reason. Okay. Now, so the most important thing is that we need to dimension it because dimensioning is kind of important, and I'll do it very arbitrarily because not very informations are given, but after trying some hit and trial before, I come to a point that okay, this is the way we can do that. So even for this, I was doing it arbitrarily, but the miss that I was getting was not exactly up to the mark. It was some variability, and then I came to the file and I saw that we can make this as 5 inches. So okay, so this point, sorry. So L14 is, let's make 5 inches. So this is 5 inches, and let's dimension the other part. So I think 5. So from this geometry, let's see. Okay, all right. Yes, so even we calculated this point, this line, and it was constituting to around 1.4458. Let's dimension this. Okay, section here. Okay, so we need horizontal, this, and this. Okay, so it's showing at 16. Okay, yeah. So this, so we don't need this actually because it's showing over dimension. So it's already been dimension like that. Mhm. Thing that is going on here. Okay, should not be a problem. Okay, but we know that this line and this line has exact dimension of what. Okay, yeah, I think this is exactly means at 17 is 7.74. Okay, should be fine. Yeah, even this is dimensioned. We don't need to worry about it. But we need to dimension this 2 point. I want to make sure. So even this thing I have done arbitrarily. So I have made it 18 inch. All right. So I think this should be fine. This is our sketch 2. Okay. So now, okay. So we need to select sketch 2. So we have made this line. So it's important that when we make this line from sketch 2, and let's generate this. All right. So now we see, even though we'll not be using this line in mesh, but I just separated the compartment and it looks good this way, and should be fine now. Okay, so this is what how we can do it. And for this length, so this is not something that we need to worry about. Even we can make it smaller or bigger. So even I made different designs and it was not exactly doing any hamper with that. So I think this should be fine, and this is how we can make a geometry like this. And now the other thing is that, yeah, so we need to make sure that this 1, 2, 3, 4, 5, 6, 7. So if you are able to make 6 or 7, even though you make this one plane or one part, it should not be a problem. So even though, so let's do one thing, that we'll be doing some projections over here. Yes. So projection. Okay. And, yes. So let's go to tool projection. So we'll be doing part by part projection. So this is edge on face because we want different face for face meshing. So let's start from here. So let's select this edge and this edge. Target should be this. Okay. Let's see. Yeah. So this is the way we can manually do it in different projections. So we'll be doing one more different projections right now. So one more projection. So I want. Okay. So I think I got some error. Just let me rectify this thing. I think, yeah, this is good. This has already been generated. Yeah, just make sureing. All right, so let's go to edge now. Okay, we'll be going for projections again. And for this part, target body. Okay, that's the problem. So point on face, of course not. We want edge on face. Yes. So now we can just select this. Okay, let's do it again. Okay. It's an important thing that we need to see if something changes over here, and that can create some problem for us. So now this edge, and let's say this edge. Okay, let's say this edge, apply, and the body will be over here. If we apply and generate this, okay, so some problem, it didn't generate. So what we'll do is we'll delete again. We'll try to do again. So even during the first time when I tried to do this, it was creating some problem. I don't know why. So let's start with other face then. This and this. Okay, the body is this. Generate. I think, okay, it did separate this from that. Okay, we'll do for this now. So for projection again, this and this, apply this face, say generate. Okay, so this compartment was isolated. All right. So this is how we'll be able to generate different faces. And so again, the point on face has come. So we need to see again, or else it will be causing some problem to us. Apply target body is this, generate. All right. So now we have different section and different face. And tool, projection. It's also point on line now. We need edge on face. And for this, we need this and this. Apply. And let's say generate. All right. So I think 1, 2, 3, 4, 5. So we need to separate this two. So for this, we'll be doing one more projection. And okay, let's remove this edge on face. This and let's say this. Everybody's good. Let's generate. All right. So we are able to successfully do it. 1, 2, 3, 4, 5, 6. Even though we can make this 2, but I don't see a point doing this here. So we will just make this one plane. And it's looking fine. Even if we don't create any plane over there, I think it should be fine. And even I tried to do it, and it was looking good. So this is the projection that we did, and the good part, just try and because we only need the surface body, so we can just hide body or not hide. So body, let's say suppress, because we don't need it. Yeah, we just need this. All right, we'll save. We're gonna save this, and then we'll be going to mesh, and from the mesh we'll be able to do how we did it. So what I will do is I'll just import my older mesh, and from that we can see how I did it step by step, and that will be a good idea to do it. So this was an important part, how to do the geometry. So I just did it hand to hand, so it will be easy for you to understand the small thing that is an important aspect. And all right, so let's get back to the mesh. All right, I'll just close this. So let's go back here. So let's open the mesh. So since these are the compartment we made, we can see it very nicely here. 1, 2, 3, 4, 5, and 6. So it's good that we have different faces. So it will be easier if you do it like this. And I have already done the mesh. I will not show you how it will look at the end, but let's do what I did. So it's an important part that to know that how we are able to do the edge meshing. So all the edge, we have different edges, so we have to make sure that every edge are sized nicely. So let's go for edge sizing. So in this, I selected this 3 vertical lines, 3 edge I have selected. Number of division I did 200, because it depends. It's a hit and trial thing. And Once you are able, it's doing so. After doing it 4 times, 5 times, I came to that. Okay, this is the amount that I need to do, and so when once I generated the mesh, I'm showing you how and what was the final number that I used. So in this, of course, biasing is important. Why biasing is important? Because this is our area of interest, and so biasing should be done, and it should be done in the opposite order. So it should come and it should be more over here. So that's why I have did it like this, and I have used a biasing factor 300. Capture curvature no, and the behavior is hard. Number of revision 200. This 3H. One more thing I have did is, if you see reverse bias, so once sometimes what happens is once you do the biasing, uh, some of those goes erected. So if you see this here, so on this I did the reverse bias. Why I did the reverse bias was because this too was biasing and coming down over here, but this was going opposite. So sometimes it happens. So what you can do in the same biasing, you can just change the direction, and once I change the direction, it was looking good. So this was the first. Now the other thing is now this part. So this sizing was done, and once you don't need to generate the mesh every time. Just do all the sizing that you want to do, and then select mesh and then generate it. So it will do automatically all the ones. So this is the edge sizing too. So I just select 3 different lines here, and in this again I did. So in this number of division I choose is 100. So again, after height and trial to look a good mesh, I did this. And for biasing again, since we need more biasing over here, that's why I did it in this way. Biasing factor I have kept as 10, and there was no need of doing any reverse bias because everything was aligning the way I wanted. So the other thing is that this 4 lines, just show you from here. Okay, so this 4 edge I did as number of division 100. This is same, and the biasing I made sure that the biasing is in upward direction because we need, since this is gonna flow, we need what's gonna happen on this region more. So the biasing should be in opposite, and even in this one of the this one I need to do the reverse bias, and it aligned perfectly, and I chose the biasing factor as 10, and then it's sizing 4. Yeah, this curve, only this curve. So this curve I have did number because this is where the Z will enter. So you have to make sure that this is nicely mixed, and this I did as number of division 200, and there was no need of bias because it should be equal everywhere. So I did this part. Now the other remaining part is this small part region and this small region over here. So yes, to see this and this I did as 25 with no biasing because again we don't need the biasing over there. But the next thing we do is this one, the bottom one. So in bottom one, we have to make sure one thing, that since this was done 200 200 division, and this was on 25 and 25, so it is around 200 plus 25 plus 25, so it's 250. That's why I did number of division 52 to make it looks symmetry in terms of missing. And this biasing was done over here. So if you see, yes, if I closely do it, yeah, the more biasing is over here. So I did biasing factor as 10. So this was done again, and this part, yeah, again we don't have to leave any edge. We have to make sure every edge is meshed nicely. And again the biasing was required because our area of interest is this, so I did the biasing here. Numbers of division is 50 because over here we don't really need any answer over there. If you see the biasing factor, I have did 100 because I just want to make it more converge over here. So this is H7. Now edge sizing 8. So for edge sizing it, what I did was select this edge and did 25 because we, as I said, it's a very less area of interest, but still we are doing the mesh. We will make sure that uh, we don't need that much division. So wherever the area of interest is more, we'll be doing the more dimension because we want the mesh to very fine over there, and the other part we don't need it because even we have to think about the quality and statistics. We don't need to surpass that. Page 9, this again, this with the biasing 175 number of divisions because this was done at 25. So, and this was done as 50. So I just try to do 75. So again, making sure that everything is aligned nicely. The other this is the final is that is inside the one, and this is a very important one too, because this is where everything is changing. So I just select this three reason, and if you see number of division, I have kept 400 because this is where everything is gonna change. So I just want to make it refined over there, and biasing, of course, the biasing should be over here more, and I have done the biasing factor as 50. It's missing. So in this you can see it's six faces because two, one, two, three, 4, 5, and 6. So all different faces, quad, and it was done nicely. The final one left is this one. So we have captured everything in this. From this to every edge, we have captured. The only thing that is left is though, even though will not be seeing any answers over there or very few changes, but to make it mesh nicely, we'll be again selecting this, and I'm selecting the same what we did as number of division 200. We could have done one thing that while doing the edge sizing one, we could have selected this and did the same thing, but uh, I thought maybe I'll do something over there, but after hit and trial, it doesn't need so much of attention, so I just did the same thing which biasing factor 300 because it's a large region, and this face is a large region, so we should make sure that whatever the edge sizing we are doing, it should blend very nicely over there, and we have to make sure that the biasing is in the down direction, so the biasing should be here more, and that's why we did in this line. So depends on how you where you want the area to be, and it's a good thing that you do. So if we'll see the mesh. All right, so this is the mesh that we are talking about. All right, so very nice. We'll see, we'll look closely. It's been meshed nicely. Denser where we want, and see over here. It's so it's good over here. Looks fine for me. And right, so this is the reason. This is the reason that we did so many different faces to, and now if we'll see the it looks very similar to this, not exact. And yeah, this is the one we are talking about, which looks very similar. This is coarser vision. This is the shear layer, how it's developing, and yeah, no, we were able to do it. So it's good if we just follow the step, and we will not be able to get to this mesh at one time. It needs some hit and trial, and because you don't know what at what number of division and what point you will be able to get that mesh. So until and unless you do it 3 times, 4 times, 5 times, or maybe 10 times, you will not be able to get it. So it's a good thing again that while doing it, you get an idea that okay, if you are able to do this, for example, I did this three, and from this I got an idea that okay, what the number of divisions should vary. So while doing this the small divisions, I was able to predict a nice number of divisions. So it comes with hit and trial, and it was a good experience for me doing this hit and trial. And so in this, even we can see the stats. So we have number of nodes element here, and which is in a good number. So we don't have to worry about being it larger. And this is the reason we made this mesh refiner over the region where we wanted, not the other ones. So it was a good idea of doing it. And the other thing is that yes, so once we go to mesh fluent, we need to make sure that we have our boundary conditions. So for this, I did this and this as free stream inlet because And even in this, they have done the, yeah. So if you see this free stream inflow conditions, they have put in this. So I have just replicated that, and this is our jet inlet. So this is our jet inlet. This is our axis of symmetry. This is the outlet. So based on this, I have just modeled it. So yeah. So this is our jet inlet. The nozzle wall, yeah. Even yeah, and this is also an important part. So the nozzle wall should all you should select everything from here because this is the wall that we are talking about. So from this to this curve, this line, and this line. So it will be a total of 5 edges. So you have to select everything, and well, I have made it at nozzle wall and outlet. Yeah, this is the outlet, and this is the part where this is the accelerometer. So this will come in handy when we'll try to reflect it in CFD post. I'll show you how we'll do it. So yeah, this is the mesh. It looks fine. Now we'll jump to Fluent. Again, I have done the iterations, and I will show you both how I did in steady and the transient one. And I will even show you how we can take the video out from the transient. So we'll see in the Fluent part. We just can cancel this. And so this was my steady state one. So we just need to open. Yeah. So you can, for you can just go to setup and number of nodes and everything need to be set. So depend on your PC. I did number of cores as 4 while doing the setup because it depends on different laptops how fast you want it to be done based on the computer power. So let's get it loaded. All right, so let's start from general. Okay, so once I went through the paper and their stats. Okay, yeah. So one more thing that our final contour should look similar to this, and that's what we are here to validate. So I'll show you once. I'll just go through about this setup, and while going through the setup, I understood from this too that we have to go with density based, and for now I have chosen steady. And this is very important that we have since we are doing axisymmetric subsonic jet nozzle, it's important that you select the axisymmetric one. And now in model, make sure that the energy is on always because where we are dealing in that. Uh, and in the method, uh, we have used Parrot Almaros because that's what they have used. It's a very basic one. They use a single equation, so it's good to go with that. Even we can try with doing other ones, but I think we'll be sticking to this. So these are the changes that we need to do in the models. The energy equations would be on, and you need to select a method. Now we'll go back to the material selection. And in this, what I have done is that uh, in the density, I have chosen this as ideal gas, and I have kept everything the same. Only thing that is changed is in viscosity. So I have choose Sutherland. And if you choose Sutherland, it goes with three coefficient method, and that's what we wanted. So we want three coefficient method, and it's already been selected. So you don't have to change anything. Just do change create, and it's done. So materials is done. Now we'll go to the boundary condition, and it's an important condition right now. So before we go to boundary condition, we need to make sure that yeah, this is an axis. So it should remain as axis. And now we have two inlets. So I'll just show you what I did in the inlet. So you can see the free stream I have used as far field and the jet inlet as pressure inlet. So if we'll go to free stream inlet, I have set. So you can just go here and it will be velocity inlet at first, but you can just change it to pressure far field from this menu. And then you can go for, so once you select it, it will come like this. Here I have chose the Mach number as 0.01 and yeah, So 0.01, how I did it is from this again. Yes. So reference as 0.01. So I did the same thing. In this turbulent and viscosity length, I have less idea about it, so I just kept it as you can even change it to 5. It should not be a problem. Yeah. All right. So this part was done, and for jet inlet, yeah. So for jet inlet, so since I have done pressure inlet, the reason I have done pressure inlet is I'll tell you. The thing is that again in jet inlet you have to come and change it to pressure inlet and go for edit. So the reason I have done the pressure inlet is that even if you see they have given a reference. So PT by P reference they have given as 1.19671. So I have done the pressure inlet over here. And so the main point is that how we got this value 19930. So this is the Gauss total pressure. So what I did was the reference atmospheric pressure is 101325. So what I did was multiplied this number with the atmospheric pressure and then subtracted it with the atmospheric pressure. So we will be getting the exact this number. So this is how a small calculation is needed while we do. And this yeah, direction vector. So 1 and 0. It was just leave it like how it was there. And for this turbulent viscosity and residue, again I have used 5. So it's good. Yeah. And so I don't have to do anything. This is outlet should be the pressure outlet because the pressure inlet and nozzle wall. So we'll not be changing anything, but I just want to show you how. So we have to make sure that there is no slip condition over here. And once you go to thermal, again there is no heat flux. So even that is an important part that it should be 0 because we are not giving any heat flux to it. And the temperature, it was around. If you see from this, it was around 297 or something like that, but I have kept it 300 because it will not be changing that much. So I have kept it as 300, and that should be even in the jet in this free stream. Okay, if we go here in this, even I have not changed any uh, temperature over here. So it was very near about that, and I want to see the changes in the same thing. So I didn't change it because it's not a much difference. So I just kept it like that. So now the other thing is that the method. So method we have choose is implicit, and I have kept everything the same. I have not played around this, and I didn't change it anything. I think this one worked fine. And so in installation, I want to do hybrid initialization because I don't want to initialize at a particular point because if you want to do that, you can just go for a standard initialization. But for this, I want to do hybrid initialization. So I want to initialize at everything. So you can just initialize it like this. Yeah. So it will just so once it shows hybrid initialization done, then you can just move forward to run calculation. So I have started with 1000, but what I got was once I started doing as 1000. Uh, at around 4000 iterations, the residual graph was balanced. So if we see the graphics, so yeah, so we have all the counters. I'll just show you how you can do this too. So so what we can do is you can always play around what iteration the solution is getting converts. So in that, the residual graph plays an important role. So if you see the values are not changing that much and the graph is steady and it's not changing that much, that's the point you can understand that yeah, my solution is converse. And while doing it, I reached up to 4000 iteration and I got the counters. So I'll just show you how the counter is. So for seeing the contours, what we can do is we can just go to graphics, contours, and just select the contour. This will open, and since we want to see the velocity how it's changing, so we can just select different versions. So we can just select velocity, we can select pressure, temperature, whatever the area of interest. So let's see in this selecting velocity, and if you Okay, so it was just it just removed because I just did the initialization, and because of that it was just change it. And just give me a moment, I'll just show you the contours. What I will do is I'll just cancel this and I will not save. So it will come like this. So I just need to reopen my uh, ANSYS once. So yeah, I just reopened it, and now I'll go to solution, and here we can see the contours and all. So yeah, so if I had done everything side by side, it would have taken a lot of time. So I just want to uh, not make a very long, lengthy video, but I just want to show you how and what we can do. So with this video, anyone can do. Just follow the step what I have said, and it should be fine. So this contour one. All right. Yeah. So I just select the velocity. So yes, you can see how it's changing, and I will even show you in CFD post that how we can make it, since this is only half, right? So we will try to put it in a way that it will look full and a nice stream of jet we can see. The other is, let's go for tracer. Yeah, so not much to take off about his changing thing. So let's go back to our solution. Don't save. I don't want to save anything right now. All right, so let's go to result. So this will open in CFD post. I don't know the reason why it was like that. Oh, so yeah, this is how it should be, but I'll show you how we can do it. So we can just select a contour. Let's say like this, and in the domain, what is important is that you have to stick to what axis we want. So like for this domain, uh, just a minute. All right. Okay. Wireframe. All right. The period. All right. So in contour, we can go to location, and location we can change it to periodic one. Yeah, we can see like that. And what you want to see is in terms of velocity. Let's apply this. Okay, so this you can increase to see a nice colors. So I just did it to 30. Yeah, so in 30, it was able to look like this. Sorry. And again, new counter you can select, because we want both the face, the upper part and the lower one. So we'll do the reverse. Contour 4, periodic 1, velocity. And in the view, you can do apply reflection, but we need the reflection on this axis. So this is our Z-axis plane. If you apply, yes. So you need to select both the counters. If you just select this, it will come only one of this. So if you select both, it will exactly replicate the one I was talking about. So that's what I did. And yes, so geometry. All right. So that's the Z I was talking about, and it looks good in this, similar to the one that has been shown. So yeah. So in the steady state, we can do like this, and we'll know how the things changes. So this is the counter we are looking for, and we finally get it. Now I'll show you how we can do this in transient, and how you can take the animation video out. So that's an other important step that we'll be following it. So let's cancel this. and I'll open this solution. So because this is the one I did the transient ones. So in transient, basically everything will be the same, but few things while doing the iterations or while doing the time step thing, we need to be a bit careful about what are the numbers we are putting there, because it's a high speed Mach number, so we have to take care of the suspect. So in general, when we go, yeah, everything remains same. Just we need to select the transient. The model will be the same, energy will be on, the viscous will be spark alarmers, so it's same. The material what we did is same, nothing changes here, nothing changes in the boundary condition. This is pressure far field, pressure inlet, everything is remains same. Yeah, if we go to method, yeah, method should be the same. Initializing, so again the after we have to do the hybrid initialization. And once you go to the run calculation, before that what we'll be doing is we'll come to this. So let's do new. So what you can do is, this is the animation. So we want to record the animation. So whatever the run calculation is going behind it, we need to see how the thing is changed in every time step. So what you can do is make sure that this is record after every one interval. Then it should be in time step, and you can do new object and go to contour. So in this, we need two different things: velocity and pressure. So let's do velocity. And once you do velocity, and if you do the save changes, it will display something like this. But of course this has already been done, so it's showing like this. But and the other thing is that once you can just zoom in the area of interest and again do the save display, and it will remain like that. While closing this, make sure that you selected the particular counter and then you pressed OK. So if you do it, so this we need to do for both the pressure. So this was for pressure, or no, this for, yeah, the counter 2 was this is for pressure, yeah. So I did one for velocity and one for pressure. And for this, I just showed you how we can do this. So before running the calculation, we need to make sure that we did this. So and run calculation, yeah, the important thing is that whatever the number of time step you do, even if you do 200 time step, it will run till 10,000 iterations, or I think 12,000 iterations I did. But we don't, because we know that 4,000 or 4,500 the solution is getting converged, so that's not our main thing. We can do this 252. I did it as 200, and this are important steps, because since this is an, so I started using 0 0.1, 0 0.5, and it was having some error while doing it. So I just decreased this to a small point, and after talking to my professor, I got to an idea that, yeah, if you decrease this and increase this, these are some of the factors that it's an important thing to run this calculator. And once I decreased this, yeah, everything was going nicely, and we were able to see uh, a nice transition video. So I did this as, so after doing some hit and trial, I just came to this number, and this number gave me a fine result. And so once you do this, you just hit calculation and wait for, and you will see the transitioning going on. And once the calculation completes, again we need to take the video out. So we'll just come back to result, animation, and play. So once you go to playback, make sure the one, so animation 1 for us is velocity and animation 2 is pressure. So select the animation 1 and just uncheck the store pay, because you want to zoom it while the video records. So you can just uncheck it and make sure that, okay, whatever the reason you want to record. So once you do this, make sure that in write record format you do video file and then write. Once you click write, it will take some time depending on the iteration we did. So for longer iteration, for number time step, it will take a bit more time than the shorter one. So once you write it, just wait for it to uh, write in video file and close it. And same thing for the pressure. Use it in the zoom view, write in the video file and close it. So once you do it, once we able to write it, we'll be able to see the videos. So I'll just show you what I had in mind. So this is my ARN2 file. So whatever the file you have saved with, go to that file, go to DPO. So this is two FFR there. I will show you what is the reason behind it. So this is my F triple F and this is triple F1. So the number of different setup you do, it increases like that. So we'll be going to my one, go to Fluent, and yes, you can see the animation. So just try to open it. I'll just open with my VLC. And yeah, it's a bit fast, but this is how it is. So yeah, so this is how the animation goes. So it's a nice view of seeing it, and this is how you can just take the video out of any animation that you did. Similarly for the pressure, this is, so it doesn't change that much over here. Yeah. So this is how we can take the video out of any animation, and this was a project that we can do in this manner, and if you follow the steps and everything. Yeah, so the most important thing that I discovered doing this project was, of course, the mesh part. And for that mesh part you need to get ready doing the geometry only. So when we start the geometry, you have to think that, okay, how I need to do the mesh. So in that geometry, if you need to make some lines or make some compartments or different faces, that's the point we need to do. And miss is always a hit and try. There is no exact point that we'll be able to do it successfully. But make sure one thing, that whatever the data we are doing in number of division or in bias, just note every point what you are doing, and try to play around with the number. And once you play around with the number, we'll be able to get the value, and that's how it is. And so this was my presentation, and so I just showed the geometry with the dimension I used. Right, so this was my mesh. This was the inlet condition that we use and different mesh procedures. And this is a simulation setup that I was able to do. So I set around 4,000 iteration. The graph was there, and just put the contour. So the basic conclusion that we can see is that uh, whatever the 2D axisymmetric geometry that we did, that exactly captured the jet flow behavior. The other thing is that the mesh refinement was done very refined, but the cell count was not excessive. So again, it's a good part that shear layer and near the nozzle helped in reducing the cell count. The two counters we plotted was velocity and pressure. The velocity counter showed that a clear jet core and mixing region with expected physics, and pressure counter showed correct boundary condition and smooth jet expansion. So this simulation step showed the turbulence model stable, and we were able to validate that with the NASA paper that we have used. So this is the thing we used, and that was all I did in the project. So thank you, everyone. Thank you so much. That's what my project.